Welcome back, guys. Today we're just going to have a quick look at this 8012A digital multimeter from Fluke. If you've been watching some of my other videos, you'll notice that a few weeks ago I picked up an 8012A from a local supplier. However, I bought it as working, 100% tested, working and everything else, so I paid a little bit more for it. And I found out that the one thing I'm most interested in this, and that is the low ohms range, wasn't working. So I brought it back and got this one. The other one was in cosmetically nicer condition. Looks like somebody's had to go with this with an axe, and there's a big chunk out of the side of it here. But that's just cosmetics. Otherwise, it looks like a fairly clean unit. It also has some acid tags welded into with a soldering iron into the surface of it. I don't know why anybody feels they have to deface an instrument like that, especially for what this cost back in the day. It just seems a little bit ridiculous. But anyway, that's it. That's the case. So what I'm going to look at today, and I'm going to take most notice, is of the low ohms range. And to help me do that, I've got my Siglent multimeter up here. And let me get a camera on that and see what we're going to do here. And I've got this resistor. It's supposed to be a 1 ohm resistor. We're going to find out about that. These crocodile clips are copper, and they generally make a pretty good connection, so I can get in there and rel out that 0.059 ohms and put this resistor across it and see what we get. Like I said, it's supposed to be a 1 ohm resistor. It's supposed to be within 5%. Well, the second thinks it's 1.018 ohms. So let's take that reading and let's bring it over here. And first we've got to go into the low ohms, which we are. And we have to zero out the low ohms. We don't have a rel switch on this. I guess this before rel switches were a thing. But what we have to do here is we have to just zero it out. So we short out the leads, and then we turn this little pot here. It's a multi-turn pot, and it's pretty nice to work with. It's not too sensitive. And we get it down here. So we're at 0. Now I get that resistor back on here again. So we're pretty close. Now, you can't really always tell because, I mean, like this is measuring down to the milliohms. And if you go out to the end of the resistor wires, you'll measure, it'll measure higher because it's actually measuring the resistance of the wire along the way here. Like that's, so we have to get it exactly the same position it was in on the Fluke or on the Siglent. So here we're at 1.015. Bring it over here again. 1.006. Even just moving the leads in and out inside the meter is going to make a difference. So we're in the ballpark. We're not far off. So it looks like we're about 10 milliohms off in the reading between one and the other. Is this still truly zeroed? Yeah. We're about 10 milliohms off. I'm happy with that. I mean, like, what I want to use that for is for finding shorts. And let me get another set of cables here, and I'll show you what I mean by finding shorts. Like, if you have the ability of measuring in milliohms, you can actually find which capacitor is shorting out your power rails just by the measurements across the capacitors. So let's put that in here and this in here. Let me go down here close to the short. There's a little wire here. It might be hard to see, but I've shorted across the two two voltage buses here with a little loop of wire, which is a fairly high resistance loop of wire, and it sort of will match what a shorted out capacitor will do. So let's put these two here beside each other and kind of null out these leads. Of course, they're going to be different than the other leads. So we've got a null there. Now we measure across the short. The measure across the short here, we get 17 milliohms. Now if we go up here just about an inch and a half away, you can see it's up to 35 milliohms. So if you're measuring across capacitors on a motherboard, you will be able to measure the one that has the short, because it'll have the lowest resistance. So that's what I want this for, especially over on my vintage computer bench, where I often have to find shorts in disk drives and in motherboards and in peripheral cards. It's going to be perfect for that. So it works in that respect. So I'm happy with it the way it is. But let's just check it out to see what it does or doesn't agree with as far as voltages and current are concerned. My 8010A, I've already checked that for the other ohms ranges, but we might even check those out as well here. But let's see if we can set up for voltage tests here. Okay, they're both measuring 14 millivolts with the power supply is currently turned off. So they're just picking that up out of the atmosphere. Let's turn on the power supply. I've got it set for 100 millivolts. And Siglin's measuring 92.7 and the Fluke is measuring 92.8. That looks pretty good to me. So let's go up to the next range. We're going to go up to the 20 volt range here. Now let's go to the 2 volt range, and I will set the power supply at 1.9 volts. Okay, Siglin's measuring 1.89 and Fluke is measuring 1.897. The Siglin's at 1.895, we'll call it. So, yeah, I'm happy with that. That's going up to 20 volts. So we should be now at 19.9 volts, or at least that's what the power supply is saying. We got 19.92 here, we got 19.90 on the Siglin. I can get up to about 64 volts. So the next range up is the 200 volt range, and we'll try to get this power supply giving us 40 volts there. So that's at 60 volts is the highest we can go. We got 60.00 on the Siglin and 60.1 on the Fluke. So far everything has been within one count. Or two counts, which if you take the precision into account, that this thing is what we would say as bang on to the Siglin. So I'm not unhappy with that at all. Let's try some current measurements. Give me a second, I'll set up for that and we'll come right back. Okay, unfortunately I can't quickly set up my system here for microamps. So I'm going to pop up at the 2 milliamp range here. And I've got the power supply set to put out 1 milliamp. So let's see what this comes up as. Okay, it looks like it's settling in at about 1.4 milliamps on both of them, 1.3, 1.4. I don't know why it's bouncing around a bit. Could be the power supply. But yeah, we're close enough. Let's go up a little bit here. Let's go up to 100 milliamps here. So we'll go up to the 100 milliamps, that's fine. Let's back it down to 20 milliamps, or I will do 19. Fluke are fond of doing stuff like that. So we got 19.25 on the Siglin, 19.3 on the, or 19.2, so we're right on. And on the 19 or the 20 milliamp scale, we're 19.26, 19.202. Well, bouncing around a little bit on the Siglin over there, but yeah, it's close enough. So I'm quite happy with this. Let's try a number of other ohms ranges. I've got my little ohms tester. So let's check it out. We've got this 1 ohm resistor here we can check out on the 200 ohm scale. And yeah, it's within one count. We'll go up to this 100 ohm resistor. I think that's within the precision. Okay, let's go up to the 2 kilo ohm scale and try this 999.77 ohm resistor. Oh. Yeah, that's good enough for me. Let's go up to the 20 k ohm scale. It's supposed to be 9.9996 k within a count. And this is supposed to be 100,000 ohms. We're in the 200,000 ohm scale here, are we? Okay, so we're, yep, I'm good with that. Now let's go up to the 10 meg ohms. Nice. And let's take a quick, I'll never use this for checking out AC at all, but let's take a quick run at that. I'll boot up my signal generator over here. While we're waiting for that to boot up, I will put this on AC volts, select the 200 volt range, and I'll check out my mains here, which is normally around about 117 volts thereabouts. Like I say, I'm not going to be using this meter for that. I've got much better meters for that purpose. 117.9, that's roughly right. The voltage around here changes from minute to minute and day to day, depending on who's got what turned on, if they're doing the laundry or not. Now let's go down, we'll go down to like the 2 volt scale. Let me set up this thing here. I'll be right back. Okay, I've got the signal generator set up for 10 volts RMS at 60 hertz, and it's measuring 9.87. I'm perfectly happy with that. As I say, I'm not going to be using this as an AC voltmeter at all. Just having a ballpark kind of figure, and this is much better than ballpark, is fine. So I am though interested in seeing where the frequency kind of dies out on it. So let's try 1 kilohertz. There's 1 kilohertz. Let's try 100 kilohertz. We're down, getting close to the 3 dB point. Let's try 200 kilohertz. So we're past it. So it's 170. Okay, we'll call it there. So that's it. So 170 kilohertz. That's good. That's perfectly good for me. That is fine. So I'm happy with this meter. I don't have to do anything to it. I might do a little bit more cosmetic cleanup on it. I seem to have misplaced the little cap over there. I know it came with it. Find that and put it on, but it's, it's got a little bit of discoloration on it, a little bit of yellowing. I don't know if I can get that off or not. I'll give it a half-hearted attempt to see if I can or not. But I'm truly happy with this. This is, I did spend a little bit more on it than I would on a non-working one fixing it, but it was $50 Canadian. I guess that's about what, $35 US. Awesome, especially for that ohms range. That's going to be wonderful. All right, thanks guys for joining me. Sorry I didn't have to get into this thing and open it up, but if you want to see what it's like inside, just go to my video where I do the calibration of the 8010A. It's exactly the same inside, except for this has got a little daughter board on it. And this one does not have the battery option, so this one is AC only. The 8010A did have the battery option, which I kind of disabled. And other than that, they're exactly the same meter. But thanks for joining me today, guys. We'll see you in the next one. Bye.